3.4 arc length and area of a sector. So we need to start out with the arc length formula. We'll talk about the area of a sector later. But arc length formula, as we went over earlier, is S equals R theta. R, of course, is our radius. S is the arc length. I guess I'll just point an arrow there. That might be a little easier, right? And then this is degrees in radians. Okay, so those are all the aspects that you will need for solving an arc length problem. Let's do a basic one. Even though we've done this in the past, I know you've seen this, but we're going to roll with it. Let's say you have a radius of 6 feet. And I just realized something. It's not degrees in radians. That makes no sense. Your angle is in radians. So let's cross that out. Your angle is in radians. That's a lot better. Your degrees are in radians. No, the angle is in radians. And then let's say our theta is equal to, we'll say the radians is pi over 4. So then you simply just multiply it, and your arc length, your S is equal to 6 pi over 4, which reduces down to 3 pi over 2. Now let's do an example where, let's say R is equal to 10 meters and theta is equal to 100 degrees. Now we need to convert in the middle of our formula. So S would be equal to 10 times, remember, conversion between degrees to radians is pi over 180. So we have to do 100 times pi over 180. And that's going to equal, well, a really big number, 1,000 pi over 180. Let me reduce that a little bit. We take one of the zeros out, divide both top and bottom by 20 at least, which will get you 9 on the bottom, and that will get us 50 up top. So 50 pi over 9 would be your solution. All right, so Ferris wheel problem. So your book mentioned how this Ferris wheel that was built in the late 19th century in Vienna, let's say, for example, it has a diameter of, let's say 197 feet. I'm going to use this figure that I drew so beautifully to the right to help us find this. So I'd start with having theta equal to 60 degrees. And we want to find the distance traveled from position P sub 0 to P sub 1. So let's start with that. That's going to be, once again, arc length, because we're trying to find the length, how far the passenger went from here to here. So that's definitely an arc length problem. When we do arc length, so we're in degrees. So once again, it's going to be 60 pi over 180 we need to include in this. Diameter, be careful. It's half of this, right? Because remember, diameter is twice the radius. So I'm going to do half of that. So 197 over 2 is equal to S. So let's multiply it out. I'm going to get rid of the 2 and make our life a little easier. Make it 30 over 180 instead. And that's going to reduce down to 197 times 30 pi over 180, reduce down to pi over 6. And then does that reduce down at all? Yes, that's divisible. Is it divisible by 3? No, it's not. So our final answer would be 197 pi over 6. If we were trying to approximate how many feet, this is a little bit more, because 197 pi over 6 is a little bit not specific and kind of hard for us to tell approximately what it is. So in feet, it's going to be approximately 100 feet traveled if we round to the nearest whole feet. All right, so we got area of a sector area is 1/2 r squared theta. theta, let's see if I can say this correctly this time. It's in radians, right? Angle in radians. Angle in radians. There we go. Cool. Given this information, let's find the sector area. So let's say we have theta is equal to 2 pi over 5, and let's say we have r is equal to 3 meters. Let's put that in. That's going to get us 9 over 2 times 2 pi over 5. That reduces it down a little nicely, so it's going to be 9 pi over 5 meters squared, because it's area. So meters squared, and if we want a more specific number, it's going to be approximately, let's round to the nearest hundredth place, 5.65 meters squared, approximately. All right, this time I'm giving you 15 degrees, and your r is 5. All right, so once again, 5 squared times theta, but it's in degrees, so we need to convert to radians, so pi over 180 must be included. That's going to get us 25 over 2, 15 over 180 will reduce. We can take a 5 out of both, right? So that will get us 3 pi over, we took a 5 out, so that's going to be 36. Ooh, can we do even more? That's pi over 12. Over 2, and in terms of this, it'll be 25 pi over 24. And if we wanted a specific number, well, first off, meters squared. A specific number, that will get us 3.27, approximately 3.27 meters squared. So let's do a little word problem here. Let's say we have a lawn sprinkler, okay? And this lawn sprinkler is at the corner of a yard, and the sprinkler is set to rotate through 90 degrees, okay? And project water out 60 feet. 90 degrees and project out 60 feet. What is the area of the yard watered by the sprinkler? So the sprinkler is going to be going all over this whole area right here. Terrible drawing, but you get the picture right here. So if it's projecting out, that means it's 60 feet, right? So 60 feet is our R, and we know that 9 degrees is our radians. You want to convert to radians right away. That's another strategy you can do. You can. It's going to be pi over 2. Well, that's nice work. That works out very nice, huh? So it's going to be 1/2 times 60 squared times pi over 2. Which will get us 3600 over 2 pi over 2. 3600 divided by 2 is going to be 1,800 times pi over 2, and that will just be 900 pi. And what will 900 pi get us? 900 pi will get us 2,827.43 feet squared. Okay? I appreciate you watching, and we'll see you in class. Bye-bye.